All right, so we are going to go ahead and start this next section here. It's going to be 26, 208, conductor termination and splices. So get in here, share my screen with you guys. There we go. All right. All right. So let's go ahead and move to the next one. All right, so we're hoping to be able to do the following: strip and train our conductors. Now, when we say train our conductors, that means we're going to actually take the conductor and we're going to put it in a position to where it stays where it is. So if I want to bend a wire to a certain angle, that conductor is going to initially try to conform back to its trained position. So you have to actually train your wires to stay in that position that you want it to be. And we'll talk more about that as we go through this. So we're talking about stripping small conductors, pretty much anything from 24 gauge all the way down to number 10. And then we're going to strip larger conductors and we're going to bend and train our conductors. So, all right, so stripping and cleaning conductors. Obviously on the left-hand side over here, we're looking at the actual size of the gauge of the conductor, known as the American wire gauge, 18, 16, 14, so forth and so on, all the way up to 2000 kc mil. This is obviously the area in circular mils. Obviously, when it gets to 200, there's no reason to do that. So that's 250,000 circular mils because we say kc, 1,000 circular mils. So there's a reason that that's 250,000. Solid, that is its overall diameter. And then, of course, if it's stranded, each conductor is on the far right-hand column. A properly made splice should last as long as the wire insulation itself. That means that when you make your connection and you make your splices and you put your wire nut on it, or you put tape or mastic or your heat shrink or whatever it is, you want to make sure that whatever you're coating it with will last as long as the original insulation. So if it's going to deteriorate faster than, say, the actual conductor insulation, then it's not appropriate. It's not approved, and you need to look at a different method. So, all right. The first step in making a connection is to trim and strip the conductors. When selecting strippers, blades refer to the normal wire, nominal wire sizes shown here. All right. So one thing to make sure you do, especially when you're dealing with older wire and some of the larger wire, especially if it's ever been heated. So what happened is when this wire superheats and it gets, when you apply too much current through it and it starts to really heat up, what's going to happen is if you heat up plastic, what is that plastic going to do? Well, obviously it's going to move. It changes from a solid to a liquid and it starts to conform to whatever is there. So what happens is when the wire gets too hot, that insulation actually starts turning to a liquid inside out and starts moving into the actual conductors themselves, especially if it's a 19 or 32 strand conductor, then that insulation will actually start embedding itself into around each of those conductors. So when you strip that wire, you got to make sure that that insulation had not melted into the actual conductors, because what will happen is when you got to make those splices and connections, it won't make a real good connection because it's got that rubber or plastic insulation actually embedded in the conductor. Just be mindful, take a look at it, make sure you clean it up properly before you make your splice there. All right. So these are, we don't use this type per se in the electrical residential commercial field. This is more for electronics and stuff like that, because you see you have your red, blue, and your yellow. Obviously red is going to be your smaller gauge wire, pretty much 14 on up to 18 or 22 right there. And then blue is going to be your number 14 to 12. And your yellow is going to be 12 to 10. Oh, there it is, says right there. Okay. So you just want to make sure that these are for butt splices. These are actually your cutting jaws. And you can see right here down one side and then down the other side. So we don't use this particular type in the electrical field because it's just not as convenient to strip your wires using this. We use the pretty much the yellow handle T strippers, a little faster for what we cut. Now, when you're looking down your strippers, if you haven't ever noticed this, you'll have, you know, one side will say solid and one side will say stranded. So your solid is going to be actually a little larger than your stranded. Your stranded is going to be a little tighter. So make sure that you're actually stripping. If it's a stranded wire, you look down the stranded side and actually strip accordingly to that size conductor. It can be cut, strip, crimp. Match the conductor size to the correct knife groove. We just talked about that. So if that's I think it's going to be about 14 gauge, 12 gauge, 10 gauge. Match the conductor size, then insert the conductor, squeeze the handles, and so forth and so on. Here's another type. It's not a type that we use in the electrical field. I've seen some of the guys come through here and they'll own a pair of these, and you know, and they're cool to have. And if you sat at a table and a bench all day and, you know, doing motors and stuff like that, I can see where those would come in handy. But out in the field, that's not a very practical tool to have. All right, for small conductors such as control signal wire, scissors type tools are preferred. Leave flat and chisel point edge to the conductor. A chisel point can make it difficult to insert the conductor in the connector. So what they're saying here is, especially on the stranded wire, if I use a type of lineman pliers and I compress the jaws across there, what's going to happen is your wire becomes very flat, and then you're having to retrain that wire to be in a circle again. So what you want to do on those is actually use a pair of electrician scissors, and literally cut them off, and it'll maintain its shape a lot better. So when you're dealing with solid wires, obviously you can use lineman pliers, diagonal cutters, strippers, whatever you want to use. Keep all your tools sharp. Proper conductor splicing, or stripping rather. When stripping conductors, remove the cable jacket to the terminal. Manufacturer recommended stripping length using an adjustable blade or die designed for the given wire size. Avoid damaging the jacket and exposing exposed wire strands before termination. So this is obviously for a butt splice. They're saying this is too long because your wire sticks out over your terminal. So this one's too short because it didn't come out all the way to the end. And of course, this one's set up perfect. So that's if you're stripping for terminal splices. Cable cutters. Look at that big old cable down there. There's probably, if I had guessed, 500 to 750 kc mil. These ratchet type cutters can strip larger conductors up to 1,000 kc mil. Yeah. Now, when you're using these ratchet cutters, they're actually designed to where the actual handle itself is not the ratcheting part. You grab onto the actual handle and you use your palm to actually ratchet the cutters. So just be mindful of that. Heavy duty cable stripper. Had Jesse actually brought in one of these at one point. They work absolutely amazing. That's an older version of what he had. He had one that literally you just clamped on it, and when you twisted it just like this, it was shaving that insulation right off that conductor. It was absolutely amazing. So definitely well worth it. Types of cable strippers can be used to strip the end of insulation to make window cuts. For example, this is exactly what we were talking about just a second ago. Jesse brought in that tool, did a spiral cut. This is the field type. We just literally will run a mark down here, and then you will score, not cut all the way through, just score around that insulation. Be very careful, don't cut all the way through. When you mark or score across any one of those conductors, it becomes very brittle and will break off on you. So follow the manufacturer's instructions to avoid personal injury and conductor damage. All right, this is, of course, that spiral tool. You can zoom in right here and look, or look in real close to your screen. This tool can be used to strip single or multi-conductor cables, make both square cuts or length cuts. Okay, so that's a pretty neat tool right there, cable stripping tool. All right, so we're going to training and bending our conductors. All right, it's the position of the cable so that it's not under tension. Bending is the position of the cable that is under tension. Proper bending and training ensures the conductor maintains its electrical characteristics over the expected life service or service life. Do not bend terminals more than 30 degrees above or below the termination point. There's a cable bender right here. Looks like these are hydraulic cable benders. Literally, like I said earlier, you just want to make sure that you have the ability with larger cable, especially larger cable copper conductors. You want to make sure that you can get those bent in a position where they're not putting a tremendous amount of tension underneath your lugs. So minimum wire bending space for your conductors per NEC table 312.6a and 312.6b. You got your wires per terminal and your size wires. Okay. Bending space at terminals. When bending space at terminals must be measured in a straight line from the end of the lug or wire connector in the direction the wire leaves terminals, or to the wall, barrier, or obstruction. So it's talking about the distance from here to here. And then, of course, part B says bending space at the terminals must be measured in a straight line from the end of the lug wire connector in a direction perpendicular to the enclosure wall. Use the values in 10 or 312B, 312.6B. So I have to look in there and get a little more. Bending space at terminals must be measured in a straight line from the end of the lug to the wire leaves the terminals to the wall. Okay. Incoming feeders connected to horizontal bus bars. Obviously, we have our lug system here. Provide the minimum requirements for the safe termination of conductors and enclosures. Overcurrent requirements can be found in 240.21. Wow, that's a quad set right here. 3-phase quad set. All right. MCC fed directly from a transformer secondary. Conductors must not be deflected within a cabinet or cutout box unless a gutter having a width in accordance to 312.6a is provided. Okay. Enclosure for switches over current devices must not be used as a junction box. Feeding through the tapping off of the switches. Where ungrounded conductors of number 4 or larger enter a raceway in a cabinet enclosure, the conductors must be protected by a substantial fitting. Okay. All right. Cabinets and cutout boxes must have appropriate space. Okay. In other words, your cabinet has to be large enough to accommodate your conductors coming in and out. They must be an adequate fitting or conductor that's actually going in and out to support those conductors. They're saying that this one right here cannot be used as a junction box. Must not be used auxiliary gutters, raceways, conductor feeding through the tapping off to other switches over current. Okay. All right. We're going to hit pause for a second and get set up on the next one here. Okay, I brought in these T-strippers just because we referenced them a while ago. I really wanted to just kind of show right here. I don't know if you can see that. Try and turn it with this. But it says right here, solid, and the other side would be says millimeter square. Normally it says stranded on some of them, but on this particular one, it has it in millimeters. So anyway, but these are your cutting teeth right here. So you would insert your conductor in here, clamp, and then of course pull and strip. So, all right, so we're going to move on to the second section of this lesson. Let me share my screen with you guys again. Okay, making a wire connection here. Install various types of connectors, make aluminum connections, and install control and signal cables. All right. These are different types of crimp-on lugs. These actually is what our power companies use primarily whenever they're tapping in and lugging or making their terminations. And it's really neat because you can see each one of these rings is essentially where the crimper will center up and actually crimp to. These will actually go from very small to actually really, really large. I've seen some huge ones. They're color coded, obviously, for different size conductors. One thing we want to make sure that we're inserting in these lugs also is make sure they're getting a anti-corrosive compound is actually inserted in them. It's either like a anti-corrosive gel or a graphite. All right, so these are different types of mechanical compression connectors. And it's just a variety of them. I mean, they make so many of them. Obviously, this is a double barrel. Parallel tap, split bolt, one barrel straight tongue. Guidelines for installing connector, review project drawing specifications for making landing line connections. Let me look in here real quick. Not that this one has anything. Use the correct tool for the connector type. There we go. Hand crimping. There we go. Installing compression connectors. Leverage crimping. You see the tool right here at the bottom has the different jaws that you can put in there for different types. Like I said, we rarely do any type of small crimping. We do larger compression, which are right here. I actually have a pair of the manual hand crimpers, but these if I did a ton of these, I would definitely own a pair of the corded battery operator or even hydraulic. Just another different type of crimper right here. And that's it, crimped right here, showing it. Actually 1, 2, 3, 4. Wow, they crimped in between each line of these. Okay. So, because it's super important. If you get a loose connection, just in any electrical connection, it creates some major electrical hazard. So definitely want to make sure we're doing that. All right, so recommend tightening torques for various bolt sizes. After conductors have been crimped in the connector must be tightened to the required tongue, or torque rather, to ensure a good electrical connection at the termination. Common torque values are shown here. We have, obviously, you can read. I don't have to read this out to you right here. All right, installing specialized cable connectors. This particular one, specialized, select the correct connector size, strip back the jacket of the armor, make sure the jacket seal and retaining spring are in their uncompressed state. Screw the connector body into the equipment, pass the cable through the connector. As you guys can see right here, step 1, 2, 3, 4, 5, 6, 7, 8. Entry component, end stop, O-ring. This is just different ones. So these are your compression type fittings right here. Let's see. All right. Pass the cable through the connector till the armor makes contact with the end. Tighten the connector body to compress. tighten the outer compression nut, and appropriate terminate individual wires. So a variety of specialized connectors can be used with application of cables. This waterproof connector should be metal clad. The specific connector, there's so many different type of compression fittings, by the way. They have EMT compression fittings, they have liquid tight, they have seal tight, Carflex, and most all of them are waterproof. The only difference is they're not necessarily all watertight, meaning that you can't necessarily submerge this like in water and expect it not to seep through. So those are the watertight connector fittings, and they are they all work the same, but they just have that extra level of protection. All right. Electricians are typically responsible for installing control and signal cables. Fire alarm instrumentation cables typically contain a drain ground wire that must be effectively grounded. Refer to the drawings. Okay, so you'll actually see a drain wire right here, and I want to say on that we got that drain wire is actually. Look here. I'll circle back on that, but there's a rule of thumb when it comes to that drain wire right there, and I want to say it has something to do with it. It's only connected at one end. I'll verify that though. I think that's a test question actually. Let's see here. All right, moving forward. All right, a basic crimp connector consists of a crimp barrel in which the conductor is inserted in a copper stud end with a bolt screw opening. The most crimp connectors are color-coded by size and insulated on the barrel end to prevent shortening to adjacent terminals. So you have your insulated part here, which is where your crimp is, and obviously this is exposed where you make your termination. These are just various different types. Color codes: red 22 to 16, blue is 16 to 14, yellow is 12 to 10. Labeled and terminated control cables. Form marking or making a crimp connection. Organize, dress, and label your conductor. Check the size and type of wire to make sure the conductor and connector's materials are compatible. Select the correct tool and die for the termination and conductor and make sure they are in good operating condition. Independent indent position. 1 is the correct indent position to essential to ensuring a good electrical connection. All right. The conductor must be properly centered in the crimp indent. A crimp over the belled mouth will compress the insulation and result in poor to no connectivity. A crimp over the inspection hole reduces both continuity and holding capacity. So like I said, you want to compress on the one right there where the two seams align right here. That's the crimp point. Once again, too much, not enough, just right. Goldilocks scenario. Yeah. Terminal blocks are available with a variety of connection types. Clamp type, spring load, screw type, terminal blocks are common. When multiple cables are installed, tie them neatly to support without blocking access to other terminal blocks. Take care to avoid routing cables over sharp edges or at a tight angle. To minimize interference, avoid wire crossovers wherever possible. Just because you got the electromagnetic field coming from higher voltage conductors, and if you run lower voltage across that or run parallel with, then you're going to get that disturbance, and just kind of want to avoid the high voltage, low voltage. All right, so let's do this. Okay, we're going to go ahead and set up with the third set here. Let me share my screen with you guys. Okay, part 3. Tape electrical connections, install heat shrink, and use motor connecting kits. Okay. Taping a motor lug connector. Obviously, you make your termination. They actually covered, taped over where the actual lug was. And then over here on part 3 is start by taping over the lugs and hardware. Joining lugs go beyond the wrap each leg. Now they're doing individual legs, and then they're coming back for a final wrap. Now, what I would typically do when it comes to lugs like that is I would take what the mastic pads is essentially what they are, and they're really thick rubberized. They're elastic. You'd stretch them, and then you'd wrap them around it, and they would literally stick to each other. And then you'd use rubber tape, and then rubber tape around it. Even if I had some liquid electrical tape prior to putting my mastic, I would put rubberized electrical tape on it, let it set up till it got somewhat hard, and then I put the mastic, then I put my rubber tape, and then I come back and put electrical tape. So that was obviously all before they came up with heat shrink. So a heat shrink is something special. All right, so this is your split bolt. God, I can't tell how many times I've had to put split bolts in. Absolutely. They will make a fantastic connection. They are just so hard to cover. So once again, you have to use that. What they're using right here, it says blah, 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 cut pieces of filler tape and place over. So they're calling it filler tape. We use a mastic pad because you can get it in a big old square, like a 4-inch by 6-inch square. And like I said, it's probably a good 8-inch thick. And you just wrap it up and make it really tight. You know, wrap it with more rubberized tape, and then of course electrical tape. Heat shrink insulators, slip wire over terminals, splices are made. So you literally you got to make. Here's the key to it. So anytime you're doing this, you're putting two together, two connectors together, 2 wires. And what you want to do is go ahead and get your heat shrink appropriately sized, slip it beyond your wire. Okay, say your termination's here. Take that wire way over here, because when you apply heat, you say you're soldering, because typically on when I splice my wires together, I like to solder them together, especially if it's smaller conductors. Then you go ahead and make your splice, and then you slide your heat shrink over it. Then you can apply the heat, and then of course it'll compress just like so. But make sure don't forget before you make your termination that you put that heat shrink on first, or else you're cutting it loose and doing it again. This is your selector guide. I'm not going to read that to you guys. You guys can read that. All right, motor connection kits. Yep. These kits eliminate the need for taping and use of filler tape or putty. Motor connection kits, once again, using your heat shrink. Yep. Okay. If you guys have any questions or concerns, feel free to reach out to me and we will discuss any and all questions you may have. Please remember to look over the section review questions in your textbook. And then, of course, if you have any questions about that, and reach out to me and we'll go over it.